Hello and welcome to Train Signal. You are watching Network Configuration and Troubleshooting. Our lesson on Internet protocols gave us an introduction to basic networking concepts, network hardware, IP addresses, and ports. That was a necessary foundation for the material that we'll cover next. Many times in your career, you'll inherit a network, hopefully a secure, efficient, reasonably smooth functioning one. But that's not always the case. If you're lucky, you'll have an opportunity to install a network from scratch. But in either case, whether it's adding new devices or computers to your network, or in the case of troubleshooting, you'll need to have a good understanding of how to configure your network. You can do this configuration from the command line, but as with other processes we've covered, there are GUI tools that can help as well. So in this lesson, we'll talk about the Dynamic Host Configuration Protocol and how to use this tool for network configuration. Then we'll move on to cover static IP addresses, ones that don't change. Next we'll discuss routing and how this traffic director moves traffic around your network internally and externally. We'll also review hostname configuration, as there will be times when you may need to set or change one. And finally, we'll tackle some troubleshooting tools and techniques. Let's begin with Dynamic Host Configuration Protocol on the next slide. Your network needs so many pieces of hardware, software, and services to work together seamlessly behind the scenes so that it appears to be a ubiquitously functioning system. In order for this to happen, though, you need a little help. Linux provides this help in the form of Dynamic Host Configuration Protocol, or DHCP. DHCP is a server, but can also function as a client. Once configured, it handles all the tough work for you. It doles out IP addresses, subnet masks, gateway router addresses, and domain name server addresses to client workstations in response to the broadcast message they send just as they boot up onto the network. You configure your DHCP server with a range of IP addresses that it can assign to your network hosts. When it receives a request, it responds using the client's MAC address, or its hardware address, and then passes along all the information that allows the two to begin to communicate. Then the client can get itself ready to connect to the network. The server takes an open IP address and assigns it to the host for a set period of time. This is known as a DHCP lease. And when the lease expires, or when the system shuts down, the IP address is released so that it can be reassigned when needed. Now there are three popular DHCP clients, and they include Pump, DH Client, and DHC PCD. And the client, of course, should be run at startup. Now depending on your distribution, this could be a sysv startup script, or for example on our Fedora test system, it uses the etc sysconfig network scripts ifcfg-eth0 file, where eth0, if you recall, is your network interface, and 0 represents the first adapter. The line that is used to enable DHCP is bootpro in all caps, followed by =, followed by DHCP. You can directly edit this file if you want to, but most administrators choose to use a GUI tool. On Debian distributions like our Ubuntu test system, the file is etc network interfaces, and the setting in this file is iface space eth0 space inet space DHCP. And to run the DHCP client manually, you need root privileges, and you simply type in DH client followed by the device name. Let's open up a terminal window and take a look at a sample DHCP configuration file, then create one of our own. In order to enable routing temporarily, we must edit the IP_forward file and change the option from 0 to 1. To do that, at the command line, we use the echo command, which is echo. Again, make sure you still have root privileges. We'll type in echo space the number 1 in quotes space greater than redirector space, and then we put in the full path to the file, which is proc sys net IPv4, and the name of the file again is IP_forward. Let's make sure we've typed that in correctly. We've got echo the number 1 to enable, and again 0 is the current setting, which is disabled. We have the greater than sign, then we've got the path proc sys net IPv4 and IP_forward. Now when you hit enter here, you're not really going to see anything happen, but that will make the change again temporarily. So go ahead and hit enter. And we know that that's temporary, so once the system is rebooted, that change is gone. And that in order to make the change permanent, again, we have to edit another file, configuration file, and that file is sysctl.conf. So let's take a quick look at that. Type in vi space etc sysctl.conf and hit enter. And we see the setting just a few lines down here, net.ipv4.IP_forward, and we see that that's set to 0 currently, which is disabled. And again, if we wanted to enable forwarding, we would hit I to go into insert mode, and we would change that to a number 1. And if you were sure of that change and wanted to save it, you would again hit the escape key and then type in :WQ to save, and the setting would be permanent. We're going to, though, go ahead and change that back to a 0, or by contrast, if you left it a 1 and hit escape and just typed in a colon, a Q, and the exclamation point, that would say to quit without saving. Now we've talked about both the ifconfig and the route command, but there are two additional tools that combine their functionality, and they are ifup and ifdown. Ifup is used to initialize or bring up an interface, and it uses the syntax ifup followed by the device. For example, ifup space ETH0. Ifdown does the opposite and brings the device down, and it follows the syntax ifdown space device. Now when you're troubleshooting, which we'll cover in a moment, being able to quickly take the network up or down can really come in handy. And so far, we've used the command line to handle configuration, largely because this is what you'll need to know for the Linux Plus certification exam. But there is, of course, a GUI option under Fedora, and it's called Network Configuration. Let's go back over to our test system and take a look at this. Click on System, Preferences, and we scroll down to Network Connections. And in the tool that comes up, we see that we have a wired tab, which includes our device ETH0. Then we have a wireless tab. If you had a wireless connection, that would show up here. We've got mobile broadband, we've got VPN, and DSL. Let's head back to wired. From here, you could add a device by clicking on the Add command. You have the option to have it connect automatically, which is probably a good idea. You can name the connection, input a MAC address, decide whether to make it available to all users, and you have some MTU information as well. You've got security options, IPv4, and if your network uses IPv6, you can set options for that here as well. I'm going to cancel out of there. And if we just click on our existing device, you can either delete it from here or edit it. And again, we have the MAC address that you could change if you needed to, although I don't see why you would need to do that. You have the connection options, You've got security options here that you can enable, and again IPv4 or IPv6 settings. Okay, I'm going to go ahead and close out of there. And we're going to bring our terminal window back up. I'm going to clear this window. I'm going to type in ifconfig again, just to start. And you can see here the inet address. Just make a note of that. Now we're going to take the network down with the if down command. We need to obtain root privileges. So let's type in su for switch user and hit enter, then enter our root password. Okay, now we're going to type in if down space ETH0 and hit enter. And we can see now that the device says disconnected. Let's type in ifconfig again and hit enter. And you can see that we no longer have that IP address that was here. Let's also type in route and hit enter. And you can see that again we don't have any routing table information because the card is no longer enabled. So let's bring it back up using the if up command. So we type in if up and we know the device name is ETH0 and hit enter. And we see here that the connection has indeed been activated. Let's try ifconfig one more time. Use the up arrow and hit enter. And you can see again we've got an IP address. Okay, let's head back to the presentation and review hostname configuration. We know that host names are just names for the computers on your network. But what we haven't talked about yet is how to configure them. You can do this one of two ways. The first is with DNS or domain name system. With this option, you add an entry to the DNS server, or alternatively, you could edit remote systems etc host file, which probably isn't the most practical option. The second way to configure a host name is locally. Now technically this name could be different from the DNS host name, but it's probably not the best idea in the world as this could easily lead to a lot of confusion. To set the host name on your local computer, you use the command hostname followed by the name of the host. Now those are the two options for hostname. By default, Linux will go to the etc host file for lookups before turning to DNS. You can change this in the etc nsswitch.conf file. On the host line, you simply will change the syntax to read hosts : space files space DNS. If you want to set your domain name, you use the command domain name. Now this sets the domain name as used by the Network Information System or NIS. DNS domain name, by contrast, sets the domain name used by DNS. Both of these commands, though, can also be used to display your current domain name. Most distributions will look at the file etc hostname first to figure out how to set the hostname. So any changes that you want to make that you wish to be permanent have to be made to that file. On our Fedora test system, that file is etc sysconfig network instead. Let's go back to the terminal and take a look at our configuration files. Now let's see if we have a host file. Let's type in cat space etc host and hit enter. Okay, and you can see that we have the IP followed by the host name. Then we have the first one for the host that's Veronica. Then we have the second one that's for localhost. Now let's take a look and see if we have the other file that is typically available on Fedora systems. Let's type in cat space etc sysconfig network. Cat etc sysconfig network and hit enter. And you can see we have two settings here, networking equals yes, and the host name again is Veronica, which we see right here. Let's take a look at how to change the DNS lookup order. From our terminal window, we'll need root privileges, so let's type in su. and type in your password. And from here we're going to use the Vi editor. So we'll type in Vi space and the name of the file, which is etsy nsswitch.conf. Let's make sure we have that spelled correctly. nsswitch.conf. And let's go ahead and hit enter. Okay, then let's go into insert mode with I, and we'll scroll down to the host line. And as you can see here, we have the current setup where we have files, we've got some other information, and we've got DNS on the end. So this is the line that you would change. So say for instance you wanted to have DNS first, you would type DNS and then just leave file second. We'll go ahead and leave it just as is, but if you wanted to make the change, here's where you would do so. Then you would hit escape to enter command mode, and from here you would type in colon, and if you wanted to make the change then you would type in WQ to save and quit, but for our purposes I'm just going to type in Q and the exclamation point to exit. Think about where you spend the majority of your time as an administrator. I'm guessing troubleshooting. Luckily, Linux has several tools to help with this most important task. One that you're probably already familiar with is Ping. This is a tool that's used to test connectivity between hosts. Ping works by sending an ICMP echo request packet from the source system to the destination, and it does so every second or so until you hit Control-C. The destination system responds with an echo response packet. Now if you don't want to hit Control-C to stop the output, you can use the ping command with the -C option, which tells it how many packets to send. For example, the command ping space -C space 5 followed by linux.com would ping linux.com and ask it to send back 5 packets. The only problem with ping is that sometimes firewalls can block ICMP requests, so keep that in mind before deciding if a system is really down or not. The next command is traceroute, and this works by sending 3 packets to each computer that sits between your system and the target system. The -N option says to show the target computer's IP instead of the host name. Tracepath is a similar command, but it gives you one line of output for each test packet, and this can make the output a little longer. Let's type in ping, and we're going to do the -C option, and let's look at 5 packets, and we'll type in trainsignal.com. You can put in any host or network computer here. And again, we're going to ping trainsignal.com and ask for 5 packets using the -C option. And let's hit enter. It should go out and ping train signal 5 times. It'll come back and tell us how much time it took. We've got 59.7 milliseconds and all the way up to 58.1 milliseconds. Not too bad. And again, ping just confirms that we have an outside connection and tells us the speed at which it's working. Now let's try traceroute. Type in traceroute followed by the host or the network. We'll try trainsignal.com again. And hit enter. And what you can see there is a bunch of asterisks. Let's go ahead and Control-C. What you'll find is that some systems actually block traceroute and tracepath data. So if you see the asterisk there, that kind of confirms it. Let's try tracepath really quickly. We'll type in tracepath and we'll do trainsignal.com again. And as you can see, we're getting no replies. Let's go ahead and stop here. and hit enter. Now again, this is a program that looks at data that's going across the network, and right now not a lot is happening. So let's go ahead and launch Firefox, then take a look at our output. And now that we see output is coming through, and this again is actually raw data that's traveling across the network. And again, if we want to stop this, we have to hit Control-C. And we can see that we had 22 packets captured, 22 received, and 0 dropped. Now let's type in TCP dump with the -A option. I'm going to close out Firefox, and then we're going to go ahead and launch it again. And if we minimize that, again we can see the output again, and that the output is stopped. The -A option, if you've noticed, is used again to display the information in ASCII format. Let's hit Control-C. Now let's use the TCP dump with -D to take a look at the interface information. Again, I use the up arrow to bring the command back up. Let's go ahead and hit enter. And here we have some interface information. We've got our ETH0, some USB port information, etc. Now let's try TCP dump with the N option, which should display information numerically. So we're going to use the up arrow to bring it back up, and we're going to substitute in the N. Let's go back to our Firefox window and click on something new so we can load some new information. Let's minimize that. And again, here you can see we don't have names anymore. We actually have numeric information, as indicated with the -N option. Okay, I'm going to go ahead and Control-C to stop that here. We've got 10 packets captured, and 10 received, and 0 dropped. And that concludes our lesson on network configuration and troubleshooting. Let's go back to the presentation and review what we've learned on the next slide. Though you can, and often will, configure your Linux network during installation, we know that no network is static. The time will come when you need to reconfigure a setting or troubleshoot network problems. So in this lesson, we learned that Dynamic Host Configuration Protocol can be used to automatically configure network clients as they boot up. And for those instances where you want to use static IP addresses on your network, we learned how to alter the necessary configuration file to do so. Then we talked about routing and how to configure routing tables to help enable communication outside your local network. Next, we covered host names that identify systems on your network and how to manually configure your network interfaces. We wrapped up this lesson with a look at Linux's troubleshooting tools designed to help diagnose issues that may be plaguing your networks. Thanks for watching, and I'll see you in the next lesson.